Hi, folks. We're welcoming Kyle Corbitt back for another conversation on fine-tuning best practices. I'm your host, Reed Mayo. I'm a founding AI engineer at OpenPipe. We are the end-to-end large language model fine-tuning platform for developers. So today's topic is going to continue our series of conversations. Last time we spoke with Kyle about training data best practices. Today, our conversation is going to focus on models themselves. We're going to talk about how to choose the optimal base model to fine-tune, including some of the common kind of trade-off decisions. We'll even touch a little bit on some performance tweaks like hyperparameter tuning as well. But yeah, so before we dive into the actual questions themselves, let's have our guest introduce himself. Kyle, tell us a bit about your background in fine-tuning and your role at OpenPipe.
Yeah, thanks, Reed. Excited to chat with you as always. Started OpenPipe, I guess about a year and a half ago. Previously had experience, I was at Google, I was at Y Combinator, a lot of time spent looking at data, trying to, figure out how to use it most effectively. And with OpenPipe, yeah, we've been working on fine-tuning for the last year and a half and have, thousands of customers who are successfully deploying models and having a good results.
Great results and a lot of fun on that journey as well. So thanks for that intro. Without any further ado, I've got a list of questions here, regarding the topic at hand. Let's go ahead and dive into it. So the first question, drum roll, is fine-tuning proprietary models like OpenAI's models versus open source. And let's, first, Kyle, let's keep the focus strictly on performance. Let's set aside factors like, cost or control issues. What are some pros and cons on, again, proprietary versus open source?
Yeah, good question. So frankly, the way we see most people evaluating this decision is OpenAI specifically. Like, let's get more narrow than just proprietary. It is theoretically possible to fine tune like Gemini Flash. In fact, we support that for some of our enterprise customers. But mostly when we're talking about proprietary fine tuning, like what's in the market right now is OpenAI's models. And they let you fine tune GPT-4o, GPT-4o mini, also some of their older models, GPT 3.5 and 4 Turbo, but those they're kind of phasing out. So it's mostly 4o and 4 mini are the models they support. We have a lot of customers. We have hundreds of models that customers have fine-tuned through OpenPipe on those specific base models. What we find is that they excel at especially smaller data set sizes. So we find that they're able to push the model behavior relatively far with a relatively small data set. So if you just have 10 examples, if you have 20 examples that you've put some time into and are high quality, you can start getting results very quickly. And I think that's probably a combination of factors, frankly. One is these are really, really strong models to start with. So even like a 4.0 is probably already going to do a pretty decent job on your task just purely through prompting. And so fine tuning is just going to take that really high baseline and move it a little further. I think that's like likely where we're seeing that. On the other hand, we see that as data set sizes get a little larger, as our customers start having a few hundred until, moving up from there into thousands or tens of thousands of examples, then we do actually see, interestingly, that you hit a performance plateau fairly quickly on 4.0 and 4.0 mini as you're fine-tuning those. And so once you're getting past a few hundred examples, you may continue seeing some amount of improvement as you add more data, but the amount is limited. Like I have my speculations for the reasons. Maybe it's just a really, really narrow LoRa or something like that they're doing internally. Obviously, that's not information they expose externally. Sure. But for whatever reason, it does seem like, you start hitting that ceiling relatively quickly. When we compare that to the open source models that we support fine tuning for, and so on our platform, that would be Llama 3.1, the 8B70B variants, as well as older models like the older Llama 3, Mistral 7B, Mixtral, some of those open source models. What we find is the inverse of what I described earlier, where with very small data sets, you may not see it be as strong as, say, like a GPT-4o fine tune, because typically these models, aren't that good, or maybe they're oftentimes a tier below just purely from a prompting point of view. But we find that as data sets get to that larger sizes, like I'm talking about a few hundred, a few thousand rows, we actually see the performance on downstream evaluations start exceeding those of the downstream evaluations on 4.0 or 4.0 mini fine tunes pretty quickly at larger data set sizes.
Okay, so the open source model will actually, outcompete in terms of performance, even a proprietary fine-tuned model as well.
That's exactly right. Yep.
Okay, interesting. Okay, cool. Yeah, so to my understanding, I knew that the fine-tuned open source would blow the doors off of the base proprietary their model, but I wasn't aware that head-to-head fine-tune you could even squeeze more performance out of an open
Yeah,
source.
no, it's frankly surprising to me as well. But yeah, we ran evals across a lot of different data sets with real customer evaluations.
Awesome. All right. Thanks for that insight. Next question, Kyle. Can you tell us a little bit about non-performance related trade-offs between proprietary and open source models?
Yeah, so let's see. I mean, one, frankly, is ease of use, and it took the open source ecosystem a while to get to a good place on that. I mean, obviously, OpenAI and then Anthropic, largely copying the same API, provides quite a good API out of the box. Very easy to use, lots of examples. Folks are familiar with it. You have basically this concept of messages, and it's quite clean actually. So it took a while for the kind of ecosystem around open source models to frankly reach the same level of ease of use. I would say at this point we're basically there, where you have multiple providers out there. You've got providers like Together, Octo, Fireworks are three large ones, Grok even, that serve these open source models and give you a nice API that looks very similar to the OpenAI one. Very easy to manage your account, kind of like build a product around that. And then on the fine tuning side, I would say we're not quite there as an ecosystem where OpenAI makes it quite easy to do it. Of course, if I can just plug my own company for a moment, like
Sure.
OpenPipe makes that extremely easy. In fact, easier to use than just manually creating a fine tune on OpenAI's side. But yeah, I think that was honestly a big part of the trade off early on. Was it was easier to use the proprietary models, and I would say like frankly that gap has pretty much been eliminated at this point.
Now that gap has been eliminated, what are reasons why you might go proprietary or you might go open source if, again, like all things equal, it's just as easy to engineer? What might be an advantage or pro and con of either?
Yeah, I mean, basically this comes back to the performance question we were talking about earlier, where I would say for a certain model size class, usually the proprietary models still have somewhat of an edge. And that's true even at the larger sizes. I would say even the largest model that came out from Meta, the 405 billion parameter one, is not quite frontier level. Like Claude has a model, Claude Sonnet 3.5, which is generally recognized as being the strongest model available anywhere right now. And as you get to smaller sizes, I think that's fair as well. Like GPT-4o Mini is an extremely strong model, priced extremely competitively. And if you look at kind of other models you can get from open source providers at a similar price point, I think GPT-4o Mini is a little bit stronger. So I think that's honestly a big part of the reason. Other reasons might be a lot of companies at this point. OpenAI I think has very, very aggressively and wisely started investing off their own balance sheet in a number of the what appear to be category winners, and kind of like there are deals there that happen that we talk to people who are like, hey, yeah, we can only fine tune OpenAI models because it's basically like the investment was just like all credits or something like that.
Sure.
So I do think that there's there's some other reasons like that, but mostly at this point I would say beyond performance there's not a good reason to stay with the proprietary ones, and we're definitely seeing movement more towards open source at this point.
Awesome. So before we get to open source, and I agree, kind of from what I'm hearing as well, it seems like the world is moving pretty fast towards open source, where it started out, it was all proprietary, a little bit open source, seems to be flipping very quickly. But yeah, so let's touch proprietary models a little bit more before we focus heavily on open source for the rest of the conversation. Like, if it does make sense for an AI engineering team to fine-tune proprietary, like you said, maybe they've got, literally an agreement with OpenAI. Are there any hard and fast rules there about outside of contractual obligations to go with AI, but like, are there any hard and fast rules on performance with fine-tuning proprietary models, like use this specific vendor for this specific task? Or is it just preference?
Honestly, with proprietary models and fine tuning, the game is mostly OpenAI at this point. Cohere does allow you to fine tune. Mistral lets you fine tune their models through their API. It is theoretically possible through AWS Bedrock to fine tune like Claude Haiku, but almost no one has access to that. In practice, I just don't see people using those, and we use those because we integrate them on our platform, and they're just super hard to use and clunky, and like, my suspicion is basically no one's using them because if they were, like, there's some like very low hanging fruit that they would fix, frankly, in the way the process works. So anyway, within proprietary models for fine tuning specifically, I think as of right now, OpenAI is basically still the main game in town.
Sure. Yeah, they're the 100-pound gorilla, so to speak. So, again, as a quick aside, you kind of talked about this a little bit with the world heading from proprietary towards open source. Do you think that's driven pretty much entirely by just a desire for control? Like companies want to basically control the model, because it sounds like cost standpoint, it's starting to feel pretty equal, and then also from a performance standpoint and ease of developer use, it's starting to be a little bit of parity. So what is driving that flip?
Yeah, great question. I mean, the thing to keep in mind here is this model is, or this market is incredibly dynamic right now. And
Okay.
so because of how quickly things are moving, the reasoning can change as well. For a long time, I would say cost considerations were the main driver for, say, the last 6 months or so. If you can hit the bar and it's good enough on the quality side, you can actually get a much more competitive model at the lower ends of the performance curve. It was just the models you would get from open source were much stronger.
And
That script has flipped a little bit with the release first of Claude Haiku and then more recently GPT-4o Mini, which are both very strong models that are priced quite low. So it'll be interesting to see going forward. I think that probably will stem the tide to some degree for people leaving purely on cost reasons. That said, like you mentioned, there's other reasons why people will do this. Certainly, like control is one of them, and we hear that from customers relatively consistently, where it's like, "Hey, I'm worried," we've got a customer who's providing, actually we have several customers, but one particular who mentioned they're concerned that's providing like a therapy bot. And they're like, I'm worried that like if OpenAI changes their terms of service and says, hey, if you're not a licensed therapist, you can't provide counseling or something like that, that we might get kicked off the platform. We want to make sure we own our own models, that we control that, and we can decide for ourselves, like what we're going to serve. Similar, we have a number of customers doing like role playing, and that like basically like I can go against what OpenAI wants to do if it's like especially as you're getting into kind of like the Adir erotic role playing stuff, which is a thing a lot of people use these models for. And so that drives people off of those proprietary models because they're worried about being cut off, basically.
yeah.
As you get to larger enterprises, there's also just a strong degree of a desire for control, just because
Mhm.
they want to control their own destiny.
Yeah.
They all things considered, they'd rather have an internal capability than a vendor, particularly if it's something that's like really core to their business, which a lot of these larger companies view, their Gen AI strategy as being incredibly strategic, and they want to make sure that that's fully within their control.
Right. Yeah. Control their own destiny. It's risky to build on someone else's platform, as companies have learned time and time again. So, kind of continuing the model trade-off decision line of conversation here, we've covered proprietary versus open source quite in detail now. Let's talk model size. Small models versus large models. What are some of the trade-offs? How do you decide which model to fine tune or which base model to fine tune on? Yeah,
Yeah,
specifically model size.
Yeah, great question. So I think a few different ways to look at this. And basically, there's two main factors to keep in mind as you're making this decision. And one is basically the size and quality of your data set. And then the other one is like the difficulty of your task, or like more specifically, the difficulty of your task relative to the kind of innate abilities of the base model you're trying to fine tune. So if you've got a relatively simple task, it's like, hey, I'm taking in emails, I'm trying to classify is this, spam or not spam, or is this like a customer support request I should send to engineering, or when I should send to billing, these kind of relatively easy tasks. Then maybe you'll look and say like, hey, like, for example, Llama 3.1 8B, which is one of the smaller models we provide on our platform, it can already get this right with zero fine tuning, like 70, 80% of the time. And we already have, 100,000 of these emails because we've been running customer support for years in our company, and we, kind of know which way it was routed. Well, then, yeah, like it's a no-brainer. You want to go for that smaller model because it's already doing a pretty good job, and you throw, a few thousand examples at it, and it's going to just like get it basically 100% of the time. Whereas if on the other hand, it's like, hey, I only have, I've got a much more complex task. So I'm trying to, let me give a good example. I'm like analyzing legal documents, and I'm trying to basically classify like, hey, does the plaintiff here have a strong case? Is this like a case I should take on or something? Like this
Sure.
requires much more complex reasoning. And I only have, like 100 cases or something that we've manually reviewed. To decide if we should take them or not. So now basically it's a much more complicated thing. And so you might say like, hey, I've tried it just purely through prompting on the smaller model size. It doesn't seem to even have any idea how to do this. I tried on a bigger one, say like a Llama 3.1 70B, and it's like, yeah, maybe it's now getting it right, 70, 80% of the time. Well, that's a strong indication that like you probably want to start from that higher model, at least initially, and fine tune on that, because, it's just going to take it's just going to be really hard to close that gap on the very smallest model if you don't have like a huge data set that's really high quality.
Okay, that makes sense. You did say that if you can get away with a smaller model, it's a no-brainer. Obviously, go with it. What makes that obvious? Is it like
Hmm.
cost or something, or?
Yeah, I mean, there's a number of advantages on smaller models. Cost is the biggest one we find for most use cases, for most of our users, where cost is basically directly proportional to the number of parameters, because it's basically, that's how many multiplications, or that's proportional to the number of multiplications that are going to happen as part of inference. And so that's basically what inference providers are going to charge you for. So that is the main advantage. Other advantages of a smaller model are latency is much better, because again, there's fewer layers it has to go through. It spends less GPU time. You're just going to get your response back faster. And depending on your use case, that could be really, really important. And finally, it gives you just more flexibility around deployments. When you're looking at these larger models, like for example, Llama 3.70b, like I mentioned earlier, most typical deployments of that are going to put it on top of like 4 different H100s. And with quantization, maybe you can get that down to like 2 H100s. But in either case, this is going to be like, you're going to have, it's going to be very expensive, and it's going to limit the number of places you can put that. Like you probably are always going to depend on an external inference provider, because like managing that yourself is a headache. Whereas if you start moving to smaller model sizes, like the 8 billion parameter I mentioned earlier, you just get way more flexibility. I mean, like if you want to take it off platform and run it yourself and just throw it on a GPU, or like if you even want to like we've had people who've exported models from our platform and they're just running them within Ollama on CPU on some random server somewhere. And that works totally fine. If you got a smaller model and you don't have like a super high throughput you're looking for, you just need to request it once in a while. So you just have more flexibility in kind of the deployment story if your model is smaller.
Interesting. Okay. Yeah. So lower cost, lower latency, and then more optionality in terms of actual deployment. Makes sense to me. Speaking of, I mean, as an aside, in terms of costs here, how long does it take to like fine tune a small model, and what would my bill look like?
Yeah. So the good news is, it's usually significantly cheaper than people expect, if they haven't done the research here. Obviously it's proportional to data set size. So let's say you have a data set, you have 1,000 examples, and each of them averages, for easy math, 500 tokens. So you've got 500,000 tokens here. Let's say you're going to fine tune that on OpenPipe. We're going to use, we have some heuristics to determine the number of epochs. Epochs is just the number of times basically we cycle through your data as part of the training run.
Okay.
And so let's say, in this particular example, we're gonna set it to 5 epochs. So now let's see, well, we're at 500,000, 5 epochs. So now we've got like 2.5 million tokens that the training run is going to see totally.
Okay.
On a Llama, like an 8 billion parameter model, I mean, we're talking maybe an hour of time. And your cost is going to be low. It's about $10. Yeah, because I think this example it's actually exactly $10. So yeah, relatively relatively small,
relatively cheap in terms of both time cost and actual money cost. And
exactly.
And then OpenPipe exposes an estimate for the money cost, so to speak, I believe, before the fine-tuning job even kicks off. Kyle, this has been absolutely awesome. I do want to talk really fast about hyperparameters a little bit, and like what are some of the common hyperparameters where people like? There's a bunch of stuff you can tweak, a lot of knobs. But what are the common hyperparameters where people see like actual results by?
Yeah. So, I mean, first of all, I would say, and this harks back to the conversation we had earlier, you're going to get the vast majority of your performance improvement by looking at your data and improving your data rather than messing around with the parameters, or frankly, even messing around with the base model. Base model, I mean, you need to make sure you have one that's like good enough that it can get there. But usually we see like it's very, very common for users to like basically move the needle much more by improving their data than say moving from like an 8 billion to a 70 billion parameter model. I just want to make sure that that's like on the record. It's like, that's the first, you should make sure you have confidence in your data. When you are training, as far as like hyperparameters and playing around with them, the main ones we see moving the needle are basically the number of epochs. And I mentioned that earlier, that just means the number of times we show your data to the model. And one interesting kind of like insight there is there's in sort of traditional machine learning, you had to be very careful with this number because there's just like a lot of research showing that if you set the epoch number too high, you end up doing something called overfitting, where it understands your test data, your training data really, really well, but then it kind of like overfits, right? It understands that too well, and it does poorly on anything that's not in that. One interesting thing we find is if you kind of like have relatively smart values for everything else, it's much harder to do that with LLMs due to a combination of factors. I think one of them is just there's so many parameters here. It has so many degrees of freedom as it's training that it can often, like, the easiest way for the model to understand your data is kind of like keeping it in the context of like all its other world knowledge. And so it's just like less likely. It definitely can happen that it forgets other stuff, and that's something called catastrophic forgetting. But in my experience, it's like less likely to happen with LLMs than others. And the other one is like we use a technique called LoRa's, which I'm sure we'll discuss at some point. But
You knew it.
but basically, like there is some amount of regularization as part of that because we're not actually updating all of the model weights. We're updating a subset of the model weights and keeping a large number of them intact. And so basically, it's a technique that helps in a number of ways, but one of them is it makes it harder to overfit. So anyway, that's just kind of an aside on epochs. You'll often hear advice from kind of more traditional machine learning, like, oh, you got to be really careful about overfitting. You got to be looking at the loss on the validation set. We find that that's less of a concern with LLMs than in other areas. So that's one thing, epochs. Another one is learning rate. Learning rate is an interesting one because basically what that means is every time you show an example to the model, it's going to get some sense of like how can I update my weights to understand, to do a better job if I see this example in the future. Yes. And the learning rate is basically how much you update the weights for every single individual example. And so, you could say like, oh, maybe I should set a really high learning rate. But basically what that's going to do is, if you set it too high, basically your updates go too far. And it's not, yeah. So it like probably would get way better at this sample, but it's like, basically paying too much attention to the sample and it's going to do way worse on everything else. And kind of like just jump around on sort of like the map of like possible weight values and not really settle. What you want to do is kind of like settle into these sort of virtual valleys in kind of like the whole landscape of possible parameter values where it does well on everything. So anyway, that's what the learning rate is. Honestly, what we found is we've done a bunch of research here, and we have pretty good heuristics on setting learning rates based on the base model, based on the data size, and a few other things. What we found is like usually, if you're using OpenPipe, you should probably just use the heuristics we have. Sure. And if you're using another platform, like I would highly actually recommend trying a few different values and seeing what you get. But like very often it's the case that you're just not going to see a big difference here. Interesting because so basically what I'm saying is there's like a relatively wide range of values we found in practice that all get you to a relatively similar spot, which has not been the case in a lot of, frankly, like, again, more traditional machine learning research where it's like really, really critical. Here, obviously, like you can mess it up if you set a value that's too high or too low, but the range of values that in practice seem to work well with the model, like within that range, it feels like it's not a hugely important hyperparameter.
Okay. So basically the hyperparameters one I'm hearing not super sensitive in the sense that you don't have to worry so much about like breaking something by being more aggressive with one of the values. The other thing though, that this may just not be worth people's time. Investing that time in making the training data better is probably going to be the best decision 99 out of 100 times. Okay, yeah, makes sense. Totally. Kyle, we've covered a lot of ground quickly. Are there any other talking points, regarding choice of base model for fine tuning that we haven't covered yet that you think might be important, or anything related to this topic you wanted to talk about?
Yeah, I mean, if you let me put in just a really quick plug, I think one of the advantages of OpenPipe is that we make it really easy to compare the same data set across different base models. So once you've got your data set uploaded on OpenPipe, it's very easy. You can fine tune the OpenAI models. You can fine tune a range of open source models. So since these are relatively cheap to run, like I was mentioning earlier. So if in doubt, like just kick off a few of them, and that's the easiest way to figure it out.
Sure. Just give it a try. Awesome. Thanks for sharing that wisdom. For the benefit of those following along, Kyle, where's the best place to reach you online for any follow-up questions folks might have?
Yeah. You can follow me on Twitter. That's just CORBTT. That's probably the easiest place. That's where I my spiciest takes, at least.
Sure. All right. That's where you live online. Awesome. Well, excellent. Thanks for sharing again, folks. In terms of if you want to reach out and ask me questions about me, I can be reached on LinkedIn. Just search, OpenPipe plus my name. Shoot me a connection request mentioning this video. We can DM directly there. But yeah, this has been absolutely wonderful, Kyle. Thanks again. Really looking forward to our next conversation on fine-tuning best practices.